Welcome to Lesson 1, Classify and Identify Properties of Polynomial Functions. Our objectives today are to identify the degree and some characteristics of polynomials for interval notation to write about in behavior. The advantage of being able to look at a polynomial and identify a bunch of characteristics is that way you can roughly sketch what the polynomial looks like so that you have an indication or an idea of what the graph may be. So here are some things that we're going to be looking at in this lesson and then in future lessons. We're going to be looking at turning points. Eventually we're going to be looking at our x-intercepts here in here, solving for our y-intercepts down here. We're going to be looking at degrees, leading coefficients, and then our end behavior. What is this end doing? What is that end doing? So first, let's classify the polynomials by degree. If we have a degree of 0, and here's an example of what a function looks like with a degree of 0, notice that we have a y, but we have no x. That's called a constant function, because if you think about the line that this function makes, it makes a horizontal line. And let's actually draw that out, and I'll show you an example. So if we have our graph, and we say that y equals -14, we would go down to -14 somewhere down here, and we would draw our line through there. Notice that our function is horizontal. This is a function, but it's a constant function because no matter what value of x that we have, whether x is 1 or 2 or 3 or anything that way or that way, our y value will always be -14. That's why we call that a constant function, and it has a degree of 0 because we have no x term. Next, we have linear functions. You're very familiar with those. This has a degree of 1. We just have an x here. So it's understood to be to the first power. We don't need to write that, but that's the degree of a linear function. A quadratic function, we just finished studying those, and those have a degree of 2. So it doesn't matter what else we have. As long as the highest degree is 2, that's considered a quadratic function. Next up is cubic function. And we will be graphing those in this week as well. And a cubic function now means we have a degree of 3. So again, we can have a degree of 2, we can have a degree of 1, as long as we don't have a degree that's higher than 3. We could even have -4x cubed, we could stop. That's still a cubic function because our highest degree is 3. And last, we have a quartic, which has a degree of 4. And again, we can have degrees of 3, or 0, or anything else. As long as our highest degree is 4, then we know we have a quartic function. Now down here at the bottom, I have written a function, and notice that it's not in standard form, meaning that it's out of order. We have our second degree first, and our fourth degree second. We have our 0 degree third, and our first degree fourth. An important part of polynomials is to make sure that you write them in standard form, which means in order, decreasing by degree. Notice that all these are in order. We go 4, 3, 0. And then this one is 3, 2, 0. This one is 2, 1, 0. And again, as long as it's in order, this one is not in order, then we're okay. So we would want to rewrite this function a little bit differently. We would want to write it in order of the highest degree and go down. So we would write it as -3x to the fourth, right? That is our highest degree here, and we want to make sure to pull that negative sign. The next degree down is the squared, and that's a positive, so that's positive 5x squared, followed by just x, so that's x to the first, and then last we have -5. So now this is in standard form and we're fine. But I wanted to point out that we still look at the highest degree, which is 4, to determine what type of function this is, and this is definitely a quartic function. Okay, let's move on to another characteristic. Let's look at the number of turning points. So here's a linear function, right? So what's our degree? Our degree is 1, thinking of a constant. Our degree is 1. Now, how often does this function turn? By turning points, I mean that it has to curve going from decreasing to increasing or going from increasing to decreasing. So in this case, we have no turning points, right? This function just increases the whole time, and this function down here decreases. So we have 0 turning points. Now let's look at a quadratic. We know that a quadratic has a degree of 2. We just looked at that. Now let's look at turning points. We only have 1. Right here is a turning point. And on this one, right here. So our graph may open up or open down, but we still only have 1 turning point. So now let's look at a cubic. A cubic has a degree of 3. How many turning points do we have? Well, if we look at this top one, we have 1 here, right? It's going up, increasing, and it starts to decrease, up, and then it increases again. So we have another one here. Same with this one. The second one is a little bit harder to spot, but we have a turning point here, and then another one here. So again, we have 2 turning points on this cubic. So are you starting to see a pattern? Let's look at the quartic. A quartic has a degree of 4, so without looking at the graph, can you determine how many turning points it's going to have based on the patterns that we're looking at? And if you said in your mind 3, you would be correct. And if we look to confirm, we have 1, we have 2, and we have 3. And on this one, it's the same, 1, 2, 3. So if we wanted to find turning points, let's just say that turning points, we're going to call that n, the number of turning points. The number of turning points is always going to be equal to the degree of the polynomial minus 1. So that's how we'll know how many times the function turns. All right, let's go ahead and erase our marks, and let's talk about something else. Let's talk about whether the function is positive or negative. So in other words, does the function open up or does it open down? So we'll get back to the linear ones in a minute, but if we look at the quadratic, this one opens up, this one opens down. So if it opens up, we say this is a positive. Okay, positive. If it opens down, we say that it's negative. So those are pretty easy, and we just finished studying those. And if you remember that when they're negative, the coefficient in front of your highest degree will also be negative. And it's hard to see, but in this equation we have a negative 1/2. So that leading coefficient would be negative in order to have it open down, in order for it to be negative. Now let's go back to the linear functions, because that's how we'll look at cubic. So in these linear functions, this top graph is obviously positive, right? We have a positive sloping line. It's going up from left to right. Whereas in the bottom graph, it is negative. It is sloping down from left to right. So again, we have the same idea as with a quadratic. If that slope is positive, the line is positive. If the slope is negative, the line is negative. So let's apply these to cubic and quartic. Now if you'll notice the difference between a cubic and a quartic, in a cubic, the cubic looks more like a linear. We have one line going, the end of one line going one way, and the end of that same line going a different direction. Whereas if you look at the quartic, both ends go in the same direction, like this, here, and on this one, here and here. So the quartic is very similar to the quadratic. Now notice the degree between the quartic and the quadratic. The degree is even. And here the degree is even. So if you have an even degree, we know that the polynomial, the end pieces of the polynomial, will go in the same direction. Whereas on this cubic is more similar to the linear. If I were to just take this end here, and I were to take this bottom end and I were to pull, say a tug of war, this would turn straight and look very much like this linear equation here. Same thing with the top one. If I were to take this bottom end and pull, and have somebody else take this top end and pull, it would look very much like this positive line here. So cubics and linear functions have degrees of 1 and 3, right? These are odd degrees. So anytime we have an odd degree, the ends are going to go in different directions. Something very important to think about. And this is also how we can tell if this is positive or negative. If we were to stretch these ends out, this would be going in the positive direction, while this one would be going in the negative direction. And the quartics are just like the quadratics. If it opens up, never mind all the little bumps in here, If it opens up, it's positive, and if it opens down, it's negative. That brings us to describing end behavior. So when we're looking at end behavior, we're looking at where the ends go, and there's a certain notation that we use when we describe end behavior. In order to use this notation, we are looking at the x-axis. So if I'm going to describe end behavior, I'm going to look at the x-axis going first towards this side, which is positive infinity, and then I'm going to look at the x-axis next, going the other direction out here towards negative infinity. So I'm going to be examining the ends of my function when it goes to the right and when it goes to the left. So I'll start all of these off like this. So what I can do is I can just take and I can write as x goes towards positive infinity here and as x goes towards negative infinity here. And I can copy and I can paste that to all my functions because that's what I'm going to be using. So let me go ahead and do that. All right, I have now added that notation to all of my functions. So that's how I'm starting off, and this is appropriate notation to use when describing end behavior. So let's finish it off for each one. All right, so as x goes this way, where is our function going? So where is our end behavior going? And remember that our end behavior, we're just looking at the end. We don't care what's happening in the middle. Well, this end is going towards positive infinity. So what we would say is our function, because this line represents our function, is going towards positive infinity. Now let's go the other direction. So as we go towards negative infinity, as we're heading out here, where is this end going? This end is going down towards negative infinity. Okay, so let's do some more positive graphs. So let's continue on with our top row because all these we know are positive graphs. So again, we're examining where these ends are going, not what's happening in the middle. So as we go towards positive infinity this way, this end is going up. As we go towards negative infinity that way, that end is also going up. So in this case, both of our function ends, I should say, are going towards positive infinity. Okay, and these are really just fancy ways to describe what I am describing in words. Now let's look at the cubic, very much like the linear. So I would expect my answer to be the same. As I go out towards positive infinity this way on the x-axis, my graph is going up. My graph is going towards positive infinity on the y-axis. And on the y-axis going the other direction, if I go out towards negative infinity, this end is then going down towards negative infinity. Notice that it matches the linear graph. These two are going to be virtually the same, just like you're about to see that the quartics are going to be the same as well. So again, if I go out towards positive and negative infinities, where are my ends going? They're both going up. So we can write it just the same as our quadratic. Our ends are both going towards positive infinity. They're both going up. Okay, so knowing what we know about positive graphs, positive polynomials, we can probably infer that if we have negative polynomials, that our end behaviors are going to be very similar based on the type of polynomial we have here. So let's first look at the linear. So as we go out this way towards positive infinity, where is this end going? This end is going down towards negative infinity. And as we go out towards negative infinity out this way, where is this end going? That end is going up towards positive infinity. Notice it's the opposite of our positive graph. So our negative graph is the opposite of our positive graph. So I would expect this is probably going to be the opposite as well. So where are our ends going here? Well, when we go out towards positive and negative infinity, both of these ends are going to do the same thing, and they're both going down towards negative infinity. So really now it's kind of redundant because we know the answer to these. These are going to be the same as our linear and as our quadratic graphs. As we're going towards positive infinity, this end here is going down towards negative infinity, and the other end is going up towards positive infinity. And then with our final one here, as our function as we go out towards positive infinity here, both of these ends, whether we go positive or negative, are going to go down to negative infinity. So these are exactly opposite of the positive graphs. And again, the ones that are even, the quartic and the quadratic, have the same end behavior, and the linear and the cubic also have the same end behavior. Okay, now we have enough characteristics to actually sit down and describe some functions, describe their graphs. So let's conclude by doing that. Let's do an example for 3 of them. So here we have 3 graphs. Let's go ahead and list what we know about each one. So in this first one, we're going to list the degree. So our degree is 3. What type of graph is this? And if you like to pause the video and you try to answer these questions about these graphs, feel free to do that and then come back and we can see how you did. So if we are raising ourselves to the 3rd power, we know that is going to be a cubic function. Number of turning points, remember that turning points are always going to be the degree minus 1, so it's going to turn twice. Is this positive or negative? Well, our leading coefficient is positive, so we know that this one is going to be positive. Let's do a rough sketch. So, a rough sketch just means sketch what it'll look like. Well, we know that a cubic function looks something like this. And it's going in the positive direction. It has 2 turning points, and that's my rough sketch. Now let's think about our end behavior. So we just want to examine x as it goes towards positive and negative infinity. So I'm going to write that out first. And then by doing this rough sketch, that can help us determine the answer to our end behavior. So as we head to the right, this end is going up towards positive infinity. And as we head to the left, this end is going down towards negative infinity. So that should be a plus. There we go. And that's it. I have described this polynomial. I have created a rough sketch. Now let's see how close we were to the actual. And that's our actual. We have it in the right direction, the right turning points, the right end behavior. Okay, let's go on to number 2 here. So for number 2, what degree is this? So if I'm looking at my degrees, I have a 4, a 3, and a 1. We always go with the highest degree. So we know that our highest degree is going to be 4. And 4 represents a quartic function. Number of turning points is going to be 3. It's always our degree minus 1. Again, let's look at our leading coefficient. That's positive. So our graph is going to be positive, which means it will open up. So if we do a rough sketch, I've got to have 3 turning points in here. So I'm going to go 1, 2, 3, something like that. It opens up. It's positive. I've got my 3 turning points. If I look at my end behavior, again, I'm going to put down first as x goes to positive infinity and then as x goes to negative infinity. Where is my function going? Well, I can look at this picture to help me. My function is going towards positive infinity. Both ends are going towards positive infinity. And let's see again how we did. Pretty good. Last but not least is this final one. This is to the 3rd power again. So we still have another cubic. The number of turning points we know is 2. This time, though, our leading coefficient is a negative 1, so we have a negative here, which means that instead of going up from left to right like this one, we're going to go down. So if I make my rough sketch, I'm going to go down something like that. And I've got to have my 2 turning points in there. And then finally, describing our end behavior, I'm going to use my rough sketch to help me describe my end behavior. So as x goes to positive infinity, my function is going down to negative infinity. And as x goes towards negative infinity, my function is going up towards positive infinity up here. And how did we do? Pretty good. There's a little bit deeper curves here than what I drew, but very similar. And really we're just making the sketch to help us with our end behavior. Okay, that concludes our lesson on describing characteristics of polynomials. So hopefully at this time you are able to identify the degree and some key characteristics of polynomials in order to create a rough sketch and describe end behavior.